Hello everyone. Today I'll be presenting our project on heart disease prediction for the course PRT 565 Machine Learning, Artificial Intelligence and Algorithms. This project was done by Sydney Group 25, which includes Sharif Muktadir Chowdhury, Puja Kumari Sharma and myself Ayush Agrawal. In this project, we built models to predict heart disease using clinical data. We tested 4 methods: decision tree, random forest, naive Bayes, and an artificial neural network. Each model was evaluated using accuracy, precision, recall, and F1 score. Our goal was to find the most effective method, showing how AI can support early detection and better decision making in healthcare. Heart disease is one of the leading causes of death worldwide. Early and accurate diagnosis can save lives, but traditional methods are often slow and subjective. Machine learning offers faster data-driven support for doctors, and by comparing different models, we can ensure more reliable prediction outcomes. We use the heart disease dataset from Kaggle, which has 1025 patient records and 13 attributes such as age, cholesterol, blood pressure, and chest pain type. The target variable shows whether a patient has heart disease or not. Since it includes both numerical and categorical data, it is well suited for supervised classification models. This is a preview of our dataset. Each row represents a patient record with clinical and demographic features. For example, sex is encoded as 0 for female and 1 for male. The CP column refers to chest pain type with values from 0 to 3, and FBS indicates fasting blood sugar where 1 means above 120 mg per dl. The last column target is our outcome variables where 1 represents the presence of heart disease and 0 means no heart disease. Before building the models, we perform an initial analysis of the dataset. Using descriptive statistics, we examine the structure and confirm that the dataset contains both categorical and numerical variables. The target variables was found to be reasonably balanced, which is important for classification accuracy. To prepare the data, we standardize the numerical features to ensure that the values like blood pressure and cholesterol are on the same scale. Categorical variables such as sex, chest pain type, and thalassemia were encoded into numerical form. Finally, we split the dataset into training and testing subset to provide an unbiased basis for evaluating the models.
This is Sharif Muktadir Hossain Chowdhury. My student ID is 374100. I will take forward the presentation to the algorithm and model overview. We applied a combination of traditional machine learning models and a deep learning model for this study. The machine learning models include a decision tree, random forest, and a Bayes. The decision tree is intuitive and interpretable, but it can suffer from overfitting. Random forest addresses this by combining multiple trees into an ensemble, producing more stable and accurate prediction. Bayes, on the other hand, is a lightweight probabilistic model that works well when features are conditionally independent. To complete these approaches, we also implemented a deep learning model, especially a multi-layer perception or artificial neural network (ANN). This model is designed to capture complex nonlinear patterns in the data and often perform well when dealing with healthcare datasets. Together, these models allowed us to compare traditional and modern approaches for heart disease prediction. The next slide is tools and programming setup. We implemented our models in Python using several key libraries. Pandas and NumPy were used for data manipulation and processing. For the models, we used Scikit-learn's decision tree, random forest, Bayes, and multi-layer perceptron classifiers. Model performance was evaluated using accuracy, precision, recall, F1 score, confusion matrix, and classification reports. To visualize the results, we relied on Matplotlib and Seaborn. Together, this ecosystem provides a robust framework for our experimentation. Here is our model training and evaluation part. The slide shows the training and evaluation of our models. On the left, the decision tree performed quite well, with accuracy close to 99%, but recall was slightly lower. On the right, the random forest clearly outperformed it, achieving perfect scores all metrics. This shows random forest is more stable and reliable than a single decision tree. In the next slide, we compared naive and the artificial neural network. Naive achieved moderate results, which accuracy around 83% and lower precision. In contrast, the NN performed much stronger with accuracy close to 97% and balanced precision and recall. This shows that deep learning was far more effective for this dataset than the simpler probabilistic approach. The next slide shows the confusion matrix for all four models. The random forest achieved perfect classification with no errors. The decision tree and NN also performed very well with only a few misclassifications. Nebes, however, made more errors, especially in predicting the negative cases. Overall, this confirms that random forest was the most accurate and consistent model for our study.
ROC curves. In this slide, we will discuss the ROC curves for all four models. Random forest and the artificial neural network both achieved an AUC of 1, which indicates perfect classification performance. The decision tree was also very strong with an AUC of 0.99, while naive Bayes was weaker at 0.90. Overall, these results confirm that the random forest and artificial neural network are the top performing models. Model comparison. This chart compares the overall performance of all four models across accuracy, precision, recall, and F1 score. Random Forest consistently achieved perfect scores in every metric, making it the best performer. The artificial neural network also delivered very strong results close to random forest. Decision tree performed well but was slightly less stable, while the naive Bayes had the lowest scores among all. Overall, the random forest proved to be the most reliable model. In this slide, we will talk about the model performance table. This table shows how each model has performed. Random forest clearly stands out with perfect scores, followed closely by the neural network at around 97%. The decision tree also did well, while the naive Bayes had the lowest accuracy. Overall, the random forest was the most reliable method. To conclude, machine learning and deep learning provides effective ways to support clinical decisions. Random forest proved to be the most reliable model for our dataset, while the neural network also delivered strong results. Simpler models like naive Bayes and decision tree can still be useful when speed or interpretability is more important than perfect accuracy. In our last slide, we have included all the references that we used in order to make our project. Our project used the Kaggle Heart Disease dataset, Skid-Learn for machine learning, and the Deep Learning book for theory, while we also used the Google Colab for the coding. Thank you.